The James Webb Telescope recently made a discovery that totally shocked scientists. This find has got everyone asking, could there be life on other planets? The telescope was focusing on Proxima Centauri b, the closest star to Earth, when it spotted something strange. It was giving off unusually bright lights, almost like the glow of city lights. But what could be causing these lights on Proxima Centauri b? Could this be a sign that life exists beyond Earth? People have been wondering about life in space for ages, and scientists have been searching for any kind of proof for years. We've always been fascinated by the idea that we might not be alone in the universe. The idea of finding signs of life outside our solar system seemed like something straight out of science fiction, but now it's getting closer to reality. This discovery has everyone excited and curious to know more. The thought that there might be living beings out there is thrilling, and any evidence that suggests it's true has been welcomed with open arms. What makes this even more incredible is how unexpected it was. The team working with the James Webb Telescope wasn't planning on discovering city lights in space, especially not from a star that's so far away. This breakthrough is a huge deal because it's one of the first solid signs that life could exist elsewhere. For years, scientists have been waiting for something like this, a solid, tangible sign that life could be out there. And now, it seems like we're closer than ever to understanding whether we're alone in the universe or if there's something more out there. If it turns out that these lights are actually coming from an intelligent civilization, it would mean that societies in space could be way different from anything we've ever known. The thought of civilizations out there just waiting for us to discover them is both thrilling and mind-blowing. The idea that these city lights have been sitting there for who knows how long, waiting for the right technology to spot them, is almost unbelievable. Do NASA engineers, when they saw these lights from 7 trillion miles away, couldn't help but wonder just how long they've been shining? How long have these mysterious lights been visible but unnoticed until now? It really makes you think about the vastness of space and how much we still have yet to discover. David Kipping, a scientist at Columbia University, explained that Proxima Centauri b is difficult to understand, especially with the strange city-like lights. The heating patterns on this planet don't match those on other known worlds, which only adds to the mystery. It's unlike anything we've seen before. The fact that these lights seem to indicate some kind of civilization challenges everything scientists thought they knew about planets and life beyond Earth. If these lights are indeed from an advanced civilization, it opens up a whole new chapter in space exploration. Exploring Proxima b is well known that most rocky planets take in sunlight and release infrared energy, but Proxima Centauri b is different. Its infrared signature doesn't match what scientists expected from a planet orbiting its star, Proxima Centauri. That's where the James Webb Space Telescope came in. It was the perfect tool to study this strange planet. The telescope is equipped to capture infrared light, and that's exactly what it did. Proxima b's unique heat signature could reveal a lot about its atmosphere, and scientists are eager to dig into that mystery. Infrared bands are one of the telescope's specialties. It can detect heat that's invisible to the human eye, and it's especially good at picking up on things like the temperature of distant planets. This technology is a game changer because it helps scientists study planets that are so far away we can't physically visit them. Proxima b, which is located around 4.2 light-years away from Earth, is an ideal candidate for this kind of research. By examining its heat signature, the telescope could uncover details about the planet's atmosphere, what it's made of, how thick it is, and whether it could support life. This is important because Proxima b is in the habitable zone of its star, meaning it could potentially have conditions that allow for liquid water, a key ingredient for life. Scientists are particularly curious about whether this planet could sustain life, so they're hoping the infrared data from the telescope will help them figure that out. If Proxima b has an atmosphere that could support life, it would be a huge step forward in the search for life beyond Earth. The telescope's advanced infrared imaging could give us a clearer picture of whether there's a chance for humans or other life forms to one day visit or even live on this extrasolar world. Most space cameras struggle to pick up the faintest rays of light across the vastness of space, but this telescope can see even the tiniest glimmers. This makes it the perfect tool to check out reports of city lights on the nighttime side of Proxima b. If those lights are real, the telescope will be able to spot them as long as the lights fall within a certain frequency range, about 1,000 times smaller than sunlight. What's really fascinating is that Proxima B's surface and its star, Proxima Centauri, create some interesting conditions. On the day side of Proxima B, there are plenty of solar features that collect energy from the star's beams. These solar panels or screens help absorb and store the energy, but they also reflect light back into space, making the planet's surface even more intriguing to study. As Proxima B orbits around its star, it experiences day and night cycles similar to Earth. During the day, the sunlight heats things up, and at night, things cool down. It's a basic cycle we know well, but what makes Proxima B so interesting is how its temperature changes in response to these cycles. This temperature variation is key for scientists because it can provide clues about the planet's atmosphere and how it responds to its star's energy. The telescope's ability to pick up infrared radiation from the planet will help scientists learn more about how Proxima B works, especially during its night phase when it's in the shadow of its star. Proxima Centauri B could have some extreme temperature swings between day and night, depending on whether it has an atmosphere. If this planet doesn't have one, the difference would be huge. The day side would be blisteringly hot, like the surface of a black body, while the night side would be pitch black and freezing cold. That's because, without an atmosphere or any kind of protective layer, there's nothing to regulate the temperature between the two sides. It's pretty crazy to think about, but if Proxima B does have an atmosphere, that could change everything. Astronomers are really interested in studying how much the temperatures change on this planet because it could reveal a lot about its atmosphere. One of the key tools they're using to learn more is the James Webb Space Telescope. It can quickly analyze the heat emissions coming from the planet, providing scientists with useful information about what Proxima B's atmosphere might be like. Thanks to the James Webb Space Telescope, it has made a potentially groundbreaking discovery while observing Proxima B, a planet orbiting the closest star to Earth, Proxima Centauri. Scientists detected unusual bright lights on the planet's surface, resembling city lights, sparking speculation about the presence of an advanced civilization. This unexpected find has reignited excitement about the search for extraterrestrial life, pushing the boundaries of what scientists previously thought was possible. While Proxima B is known to absorb and emit infrared radiation like most rocky planets, its heat signature appears unusual, further deepening the mystery. David Kipping, a scientist at Columbia University, highlighted that the heating patterns on Proxima B don't match those of other known exoplanets. If these lights are artificial, it could suggest the existence of intelligent extraterrestrial life, marking one of the most significant discoveries in space exploration. The possibility that these lights have been shining for an unknown period, unnoticed until now, raises profound questions about what other cosmic secrets might still be waiting to be uncovered. If confirmed, this discovery could change our understanding of the universe and our place in it. Scientists, by using a powerful infrared telescope to study Proxima B, a planet located 4.2 light-years from Earth, the telescope detects heat signatures, helping researchers analyze the planet's atmosphere and determine if it could support life. Since Proxima B is in its star's habitable zone, there's a possibility it could have liquid water. Infrared imaging allows scientists to study Proxima B's temperature changes between its day and night sides. If the planet lacks an atmosphere, it would experience extreme temperature swings, scorching hot on the day side and freezing cold on the night side. However, if it has an atmosphere, it could regulate these temperatures, making it more hospitable. Researchers are also investigating unusual light patterns that could indicate artificial city lights on Proxima B's night side. Additionally, the planet's surface might have reflective solar panels or screens absorbing and storing energy from its star, Proxima Centauri. This advanced infrared study could provide critical insights into whether Proxima B is a potential candidate for life beyond Earth. Scientists are using the James Webb Space Telescope to study Proxima B's temperature changes, which could reveal key details about its atmosphere. The telescope's ability to detect infrared light allows it to analyze the planet's heat emissions, providing insights into its climate and potential habitability. Since Proxima B's orbit lasts 11.2 Earth days, Webb can observe its full day and night cycles, helping scientists determine if its atmosphere can regulate extreme temperatures. If Proxima B has an atmosphere, researchers will analyze its chemical composition for gases like oxygen, methane, and water vapor, key indicators of life. By studying how light passes through the planet's atmosphere, they can identify these elements, much like reading a fingerprint. This technique was previously used by the Galileo spacecraft to detect a biosignature on Earth, sparking hope that similar signs could be found on exoplanets. Webb's advanced spectroscopy could also detect artificial chemicals like chlorofluorocarbons, which might suggest the presence of an advanced civilization. Discovering such chemicals would be groundbreaking, offering potential evidence of intelligent life beyond Earth. Scientists are eager to explore these possibilities, using Webb to map exoplanets' inhabitable zones and determine if life, either familiar or entirely different, exists elsewhere in the universe. Scientists are expanding their search for extraterrestrial life beyond Earth-like conditions, considering extremophiles, organisms that thrive in extreme environments, as proof that life can exist in unexpected places. These hardy microorganisms survive in extreme heat, acidity, and radiation, challenging previous assumptions about habitability. This realization has broadened the search for life to include planets orbiting red dwarf stars, which are cooler and dimmer than our sun but incredibly long-lived, giving planets ample time to develop life. One exciting discovery in this field is the TRAPPIST-1 system, located 41 light-years away in the constellation Leo. It consists of 7 rocky planets, 3 of which lie in the habitable zone, where liquid water could exist. Scientists are analyzing the light from TRAPPIST-1 to determine whether these planets have an atmosphere similar to Earth's, making them prime candidates for further study. Closer to home, Proxima b, discovered in 2016, continues to intrigue astronomers. This exoplanet, located just 4.25 light-years away, orbits Proxima Centauri in its habitable zone. While it receives enough sunlight to potentially support liquid water, it faces harsh conditions, including strong solar winds that could strip away its atmosphere. Scientists are eagerly studying Proxima b's size, mass, and atmospheric composition to determine if it could support life,